Hi folks, welcome to the 9.3 video part 4. And in this part, we're going to take a look at an applications question for solving a first order linear differential equation. Okay, so in example 6, we have the following question. An initial deposit of $10,000 is made into an account earning 8% interest compounded continuously. Money is then constantly withdrawn at a rate of $1,000 per year until the account is depleted. Find the amount in the account at any time t. When will the amount be zero? What is the total amount withdrawn from this account? So this is a really common kind of scenario where, you might have a savings account or maybe like an investment account, something that's earning you interest, but like even though it's making you money, you're also taking some out, like maybe your $1,000 a year to pay for part of your car payments or, go towards your textbooks and food or something, right? So like it's not just the ideal where we're saving, but like sometimes what we're saving, we do then take out a bit. But because it's earning some interest, we actually have more than $10,000, right? So the question is kind of like, how much money will we have over the course of the time of this account? So laying in these words is actually a first order linear differential equation, all right? So I'm going to write a couple things out and we'll use that to create our equation. So it turns out that the rate of change of the amount, right? The rate of change of the amount is actually equal to the rate of growth minus the rate of withdrawal. Okay, so let's look at this for a moment. So how the account is changing depends on how much it's growing minus how much you're taking out, right? That's really what we've got going here. So let's now apply some variables to this. The rate of change of the amount, we can call this a prime. Okay, so prime because it's how the amount is changing. That is equal to the rate of growth, which is going to be our percentage times the amount in the account, and then minus our rate of withdrawal, which in this case is a constant amount. All right, so I'm withdrawing the same amount every time. So it's a constant. Now, what does this give us? We get A prime equals RA minus M. But if I want to write this in the standard form for my first order linear differential equation, I'm going to subtract the RA to the left-hand side. So we're going to get A prime minus RA equals negative M. This is going to be our standard form for our first order differential equation. Okay, now we do have some of these numbers, so let's see what they are. All right. So step 1, our standard form. So I know that A of 0 is 10,000. Like my initial deposit is $10,000. I also know that I am taking out $1,000 every month. So my M is, or well, my negative M is negative 1,000 because I'm like subtracting $1,000 every time. Okay. But I also know that the rate at which the interest is compounding is 8%, but we want to make sure to turn that into a decimal before we use it in our equation. Okay. So if we take all these things into consideration, we've got A prime minus 0.08A minus equals negative 1,000. And then our A of 0 equals 10,000. That is our initial condition. Okay, so we're going to need that at the end. Well, now that we've got our standard form, we're going to treat this like every other question we've worked on. We're going to find the integrating factor. We're going to multiply that integrating factor across. We're going to use that idea of the product rule to help us get our y all by itself. Okay, so let's find our integrating factor. Our integrating factor is e to the integral of our f of x. Okay, so negative 0.08 x, no x, dx. That is our integrating factor. Okay, now when we integrate, we are finding we are finding our integral, so negative 0.08x. That is our integrating factor, and that is what we are going to multiply our standard form equation by. So e to the negative 0.08x times a prime minus 0.08a equals negative 1,000. Okay. All right, let's distribute, see what we get. We get e to the negative 0.08x times a prime minus 0.08 e to the negative 0.08x times a equals negative 1,000 e to the negative 0.08x. Okay, just multiplied out. Now let's think about what is our u, what is our du, what is our v, and what is our dv. Okay, so u is over here, which makes sense because our du is that whole thing because we have to use chain rule. Okay, this is my v, this is my dv. So what that means is I can write this left-hand side as the derivative of u times v equals my left-hand side. Okay. Now we're going to go ahead and integrate. The integration is how we get rid of this derivative, which is ultimately how we're going to get this a all by itself. Okay. So we integrate the derivative. And that's equal to, if we integrate one side, we got to integrate the other side. Okay. Integral and derivative cancel out. So my left-hand side is just e to the negative 0.08x times a. Now, when I integrate the right-hand side, though, this tells me I don't want to use chain rule because I'm not taking a derivative. I need to use u sub. Right, so I set my u equal to the negative 0.08x. My du is negative 0.08. I'm going to divide that negative 0.08 over to the left-hand side. And then I'm going to make my substitution. So I get negative 1,000 divided by negative 0.08, the integral of e to the u du. All right, e to the negative 0.08x times a is going to be 12500 e to the u. So let me put that u back in, plus c. Okay, we're almost there. Our step 5, we got to go ahead and isolate our A. And then because we have some initial conditions, we do have to plug those in so we actually get a value for C, and it's not just a random plus C. Okay, so A equals 1, 2, 5, 0, 0, e to the negative 0.08x over e to the negative 0.08x plus c over e to the negative 0.08x. All right, always look to simplify because check out what I can reduce. That's really nice. So I get A equals 12500 plus C over E to the negative 0.08x. All right, now this would be our answer if we were looking for a general solution. But remember, way back at the beginning, we had some initial conditions. A of 0 equals 10,000. So let's use that in the bottom to help us find our C value. Okay, so A of 0 equals 10,000. And we know that e to the 0 is 1. And so we end up with C being negative 2500. Okay, so let's put that all back in, see what we get. We get A equals 12500 minus 2500 over e to the negative 0.08x. Okay. Now, for those of us who are like, ooh, we got a negative exponent on the bottom, can we bring it up to the top? And we absolutely can. So we could write this as 12,500 minus 2,500 e to the positive 0.08x. Okay. All right, so this is our solution. This gives us the amount in the account at any time x. But then the question asks, when will the amount be 0? So we got to figure out when is A going to be 0, okay? So let's figure that out. 0 equals 12,500 minus 2,500 e to the 0.08x. All right, I'm going to add the 2,500 e to the 0.08x to the left-hand side. And now I'm going to divide by 2,500. So let's see what we get. 12500 divided by 2,500 gives me 5. So e to the 0.08x equals 5. All right, we got to use our exponential equation solving skills. We're going to natural log both sides. So that's going to give us natural log of e to the 0.08x equals natural log 5. The beauty of this, natural log and e cancel. So I'm going to get 0.08x equals natural log 5. And I get natural log 5 over 0.08 gives me my x. And when I type this into the calculator, I get 20.118 years. Okay. So believe it or not, you have your $10,000 in there. It's earning money. And instead of it all being gone in 10 years, right? Because if you take out $1,000 a year, you think this account's only good for 10 years. Because you're earning interest, this account actually lasts you over 20 years. Okay, so I'm not one to be giving financial advice at this time in our economy, but if you can get an account that is earning you interest, it's actually pretty powerful if that interest rate is high enough. Okay. All right. So what was the last bit of the question? It says, what is the total amount withdrawn from the account? So what we're going to do is we're going to take 20.118, all right? 20.118 and we are going to see how much money we have at the end of that time. And I'll leave those calculations to you, but I believe you should have that amount of money that you put in or that you've earned. And so you end up having a whole lot more than just that $10,000 that you put in at the beginning. Okay. So power of interest, if you get an account with a good, consistent interest rate, it will definitely pay off. All right, folks, that's it for today. Hope you're doing well, and I will see you soon.